The scientist who changed the world with a mistake. The paradox of progress. Science is often portrayed as a steady march toward truth, a precise, logical unfolding of discovery. But in reality, science is messy. Some of the greatest breakthroughs came not from perfect planning, but from errors. Mistakes that opened doors no one even knew were there. This video explores the fascinating world of scientific mistakes, how one misstep, miscalculation, or misinterpretation changed not just the course of science, but the course of history. We'll look at how blunders by famous scientists like Alexander Fleming, Alfred Wegener, and even Albert Einstein led to monumental shifts in our understanding of the world. Mistakes are not the enemy of science, they're often the engine of progress. At first, let's look at the accidental revolution of penicillin made by Alexander Fleming. In 1928, Alexander Fleming returned from vacation to find mold growing on one of his petri dishes. He noticed that bacteria near the mold had been destroyed. Many would have discarded the dish. Fleming investigated. What he discovered, penicillin, would go on to save over 200 million lives. But Fleming himself wasn't able to purify or mass-produce it. That came years later through the efforts of Florian Chain. Fleming's mistake wasn't realizing what he had done, but that mistake cracked open the door to the antibiotic era. Scientific fact: penicillin inhibits bacterial cell wall synthesis, killing a wide range of bacteria without harming human cells. So the greatest medical revolution in history began with an unclean lab. In addition, let's look at the dismissed theory that became geological fact: Alfred Wegener. In 1912, Alfred Wegener proposed that continents drifted. His evidence: similar fossils across oceans, the fit of continental shelves, and geological similarities. But he had no mechanism for how continents could move. His idea was mocked for decades. It wasn't until the 1960s, long after his death, that plate tectonics and seafloor spreading confirmed his theory. Scientific fact: mid-ocean ridges and magnetic striping on the ocean floor validated continental drift. So again, a wrong-sounding idea with no mechanism can still be right. Now we are moving to the equation Einstein called his biggest mistake. Einstein's equations predicted an expanding universe. But in 1917, he believed the universe must be static, so he added a term to his equations: the cosmological constant lambda, to force the universe into balance. In 1929, Edwin Hubble discovered the universe was indeed expanding. Einstein later called his constant the greatest blunder of my life. Ironically, the cosmological constant came back into cosmology in the late 1990s as a model for dark energy, the force accelerating the universe's expansion. This helps us understand that what seems like a mistake may be ahead of its time. The ozone hole, misinterpreted and nearly ignored. In the early 1980s, British scientists Joseph Farman and his team noticed drastically declining ozone readings over Antarctica. They initially thought it was an equipment error and nearly discarded the data. But it was real. Chlorofluorocarbons, CFCs, used in aerosols and refrigeration, were breaking down ozone high in the atmosphere. Their insistence on checking and rechecking what looked like a mistake led to one of the greatest environmental interventions in history: the 1987 Montreal Protocol, banning CFCs. Scientific fact: one CFC molecule can destroy over 100,000 ozone molecules. One of the biggest revolutions in the discovery of insulin, a life-saving incidental finding. In 1921, Canadian scientists Frederick Banting and Charles Best were conducting experiments on dogs, attempting to find a cure for diabetes. Their goal was to isolate a hormone that could regulate blood sugar levels. During the experiment, they accidentally overheated one of the glands they were studying, but this led to an unexpected result. Instead of continuing to work with the usual tissues, they decided to try secreting the hormone from another part of the pancreas. Upon testing, they soon discovered that the hormone they isolated, insulin, indeed lowered blood sugar levels. This discovery, although a result of a random mistake, revolutionized medicine. Insulin became key in treating diabetes, and since then, it has saved millions of lives. Before this breakthrough, diabetes was practically a death sentence. But with the help of insulin, people were able to live normal lives. So why mistakes matter in science? Science isn't just a collection of facts. It's a method of trial, error, and revision. And sometimes mistakes open the biggest doors. They reveal where assumptions are wrong, where tools are limited, where nature surprises us. The key is to stay curious, question anomalies, and embrace the unexpected.